Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today our group are going to present about polymer production, which is polymerization process and production of LDPE. So this is our group members. My name is HAZIM bin YUSOF. Second, Muhammad NAZMI ZUHAILI bin IBRAHIM, and the last one is Muhammad Afiq Aiman bin JAMALUDDIN. Now I am going to present about the introduction for this topic. Since prehistoric times, natural polymeric materials such as wood and horn have been employed. Modified form of natural polymers such as vulcanization of rubber, modified form of cellulose, which are cellulose nitrate and cellulose acetate, have been developed over the previous century. The phenol formaldehyde resins discovered around the turn of the 20th century were the first entirely synthetic polymers. Since then, the synthetic polymer sector has grown dramatically for the manufacture of plastic or thermoplastic. The largest class of polymer by far is about 85% of synthetic polymers. Plastic were produced in around 265 million metric tons over the world in 2010. This is the highest demand of plastic in Europe. Figures from the world reveal a similar pattern. Next, above a certain temperature, plastics become flexible solids, and when cooled below that temperature, they become rigid again. On warming and cooling, this flexible or rigid cycle can be repeated. When plastics are flexible, they can be molded into shapes that remain hard after cooling. PET and the polyamides, nylon and Kevlar, for example, can be drawn or pulled out into strands with high tensile strength and durability. Non-fibrous product cannot be processed in this way. Thermoset resins such as phenol formaldehyde and synthetic polymers are two more types of synthetic polymers. The rubber such as styrene butadiene, rubber and SBR. Thermoset resins, which is network copolymers, do not become flexible until the temperature rises to the point when thermal disintegration takes place. Rubbers made of synthetic materials or elastomers can be significantly deformed by a slight stress, yet they revert to their normal shape once the stress is removed. So that is all from me. Thank you. I will now pass to NAZMI ZUHAILI.
Okay, so I will continue for the polymerization isotonicity. The main difference between polymerization process and the process for the manufacture of smaller molecule lie in the fact the polymer system are highly viscous. In chain growth, polymerization, an extra challenge is the often high isotonicity of the reaction. The reaction enthalpy for the polymerization of ethene has one of the largest negative value with an accompanying excessive diabatic temperature rise of circa. In addition, at temperature above about 570 Kelvin, ethene decomposition into carbon, hydrogen and methane poses a serious threat. This reaction is highly exothermic and once started is difficult to control, leading to a thermal runaway. Hence, very special attention has to be paid to temperature control in the polymerization of ethene, both to ensure polymer quality and safe operation of the process. Okay, next, the second part is production of LDPE. This part will be presented by me, Muhammad ZUHAILI, and Afiq Aiman. Okay, firstly for the polyethylene background information. So firstly is catalyst development. So the chance discovery in 1935 by ICI that ethene can be polymerized at very high pressure, which is over 2000 bar, to produce a high molecular weight semi-crystalline material, was the starting point for the manufacture of polyethylene. After the discovery of polyethylene material, which with high density, it was called low density polyethylene, LDPE. So LDPE was first produced commercially in United Kingdom in 1938. In the 1950s, Ziegler and Natta discovered titanium and vanadium-based catalysts capable of polymerizing ethene at lower pressure than those used in the production of LDPE. The polymer formed by this new process had a higher density than LDPE and thus was called high-density polyethylene HDPE. At about the same time, researchers at Phillips Petroleum Co. discovered that catalysts of chromium oxide support on silica were also capable of producing HDPE at moderate temperature and pressure. Phillips catalysts are less active than Ziegler and Natta catalysts. and therefore are limited to the production of polyethylene. Commercial production of HDPE started at the late 1950 using both type of catalyst system. HDPE produced with this catalyst is linear without branching. Since the introduction of the original Ziegler-Natta and Phillips catalyst, a lot of development work has been performed. This development have made possible of control of physical properties and molecular weight. The addition of 1-alkene during catalytic polymerization of ethane results in polymer with a density similar to LDPE or lower. When higher 1-alkene are added, the resultant polymer chain will have short branch. These are all the same length since they are simply the rest of the 1-alkene molecule. Okay, next for the classification and properties. In the previous section, the three most important polyethylene classes, namely LDPE, HDPE and LLDPE have been encountered. So the table below give a commercial classification of the various polyethylene. The polymer density and crystallinity depends on the degree of branching as well as on the molecular weight. Linear unbranched polymer has a more densely packed molecule structure and hence contain larger portion of crystalline order material than branched polymer. This is due to the interference of the side branch with the alignment of the polymer chain. In the figure below on the right side, summarize the chain structure of the main polyethylene. In the case of LDPE production, the polymer density is controlled by the operating temperature. A higher temperature results in more side reaction, causing branching and hence a lower density. In a lower pressure catalytic process to produce HDPE and LLDPE, the density is controlled by the type and amount of comonomer added to the polymerization reactor. Common comonomer are 1-alkene ranging from 1-butene to 1-octene. With increasing density, certain polymer properties increase, for example, yield strength, stiffness and impermeability to gases and liquid, while others decrease, for example, transparency and low temperature breathness resistant. Okay, the next is the application. In 2007, the world production of polyethylene was approximately 80 million metric ton, divided mainly among LDPE, LLDPE and MDPE, and HDPE is roughly equal share. LDPE has a wide variety of application, of which those requiring processing into thin film take up the largest segment, which is 60 to 70%. Polyethylene film application include food and non-food packaging, carry out bags and trash can liner. Other application of LDPE include extraction coating, like for packaging of milk, injection molding for the production of toy, and sheeting for wire and cable. LLDPE is replacing LDPE in film application, which is now the largest outlet for LLDPE, which is about 70%. Injection molding and sheeting for wire and cable are other important application. LLDPE is less likely to replace application requiring extraction because of its lower flexibility and lubricity. Neither is LLDPE used in application requiring high clarity. The major application of HDPE is in blow molding to produce, among other things, milk bottle, container, drum, fuel tank for automobile, toy and housewares. Other large outlet are film and sheet. For UHMWPE is used in special application requiring high absorption resistance, such as bearing, sprocket and gasket. So that's all from me. I will pass to Afiq Aiman for the next presentation.
Okay, thank you Nazmi. Bismillahirrahmanirrahim. So I will continue the presentation. Production process. The production of LDPE is very interesting because of the combination of a very high pressure and a high propensity to run away of the reacting system. Safety is crucial for the survival of a chemical company, and LDPE production plants are very instructive in this respect. The formation of LDPE proceeds through a radical mechanism without a catalyst. Therefore, a relatively high temperature and very high pressure are required. At the high pressures used, ethene behaves like a liquid and it is a solvent for the polymer. LDPE is produced in either a stirred autoclave, which is CSTR, or a tubular reactor, which is PFR. Polymerization reactions. Polymer are high molecular weight compounds formed by the aggregation of several small molecules called monomer. The plastics that have changed nature and synthetic fabrics used in clothing are polymers. There are two basic ways of forming the polymers. Number one, connecting small molecules together is a type of addition reaction, which is called chain growth polymerization. Number two, combining two molecules of the same or different type with the removal of a stable small molecule such as water. This latter type of polymerization combines addition and elimination reaction, which is called step growth polymerization. So for the chain growth polymerization, chain growing polymerization is a process in which the high molecular weight polymer is formed early in the polymerization process, and the yield of the gradually increase over time. Addition reaction. Chain growth polymerization is a chain reaction that adds new monomer unit to the growing polymer molecule, one at a time, through double or triple bonds in the monomer. The first step is initiation. A free radical initiator attacks the carbon-carbon double bond. Second, propagation. The new free radical compound interacts with another alkane, continuing the process of chain growth. The last one is termination. Occurs whenever two free radicals encounter one another. The two free electrons form a covalent bond and the free radical on each molecule no longer exists. Step growth polymerization. The stepwise reaction between bifunctional or multifunctional monomers in which high molecular weight polymers are formed after many steps. In contrast to chain growth, all monomers are reactive. Therefore, most monomers are consumed early in the polymerization to form short chains oligomers that combine to long polymer chains, a later stage of the polymerization. Condensation reaction, a form of step growth polymerization in which two molecules combine. The combination of two identical molecules is known as self-condensation. Aldehydes, ketones, esters, alkynes, and amines are among several organic compounds that combine with each other or among themselves to form larger molecules, except for amines. Catalysts commonly used in condensation reaction. So for the process equipment, the first one is third autoclave reactor or CHTR. This reactor can be considered to operate adiabatically with very high temperature and pressure. The conversion must be limited in order to limit the temperature increase. Another reason to limit the conversion is the increased viscosity with a higher polymer content, which makes stirring difficult and can lead to local hotspot. This is the CHTR diagram. The second one is tubular reactor or PFR. Operates at a high temperature and pressure. The tubular reactor is essentially a long double pipe heat exchanger. The tubes are surrounded with jackets in which a heat transfer fluid circulates. In the final parts of the reactor, the temperature of the reaction mixture decreases. To achieve the high velocity required for effective heat transfer to the cooling jacket, the reactor pressure is controlled by a cycle valve that opens periodically to reduce the pressure. This is the PFR diagram. Due to the low heating conversion, a recycled system is required. This is similar for both the autoclave and the tubular reactor. The high pressure separator separates most of the polymer from the unreacted monomer. The separator overhead stream containing ethene and some low molecular weight polymer or waxes is cooled, after which the waxes are removed. The resulting ethene stream is recycled to the reactor. The polymer stream leaving the high pressure separator is fed to a low pressure separator where most of the remaining ethene monomer is removed. This ethene is also recycled to the reactor. Some ethene is purged at this point to prevent accumulation of feed impurities. The molten polymer from low pressure separator is fed to an extruder, which forces the product through a die with multiple holes. Polymer strands are cut underwater into pellets of about 3 mm diameter and then dried into the centrifugal dryer. The third equipment is ethene compressors. High pressure was first applied at the end of the 19th century for the liquefaction of the so-called permanent gases such as oxygen and nitrogen. For the production of LDPE, the maximum attainable discharge pressure of centrifugal compressors is not nearly enough. With reciprocating compressors, higher pressures can be achieved than with the centrifugal compressors. In LDPE plants, a primary centrifugal compressor is used to raise the pressure of ethene, and a secondary reciprocating compressor, often referred to as a hypercompressor, is used to increase the pressure. The development of reciprocating compressors for these high operating pressures and high throughputs was not an easy task. Several problems had to be solved, such as ethene leakage past the plunger, breakage of the plunger due to misalignment, fatigue failure of high pressure components. Ethene leakage is not only means a loss of ethene but also represent as an explosion danger. Plunger misalignment is the most common cause of failure of the compressors. Plunger breakage may lead to serious fires due to a large escape of ethene. So that's all from us. Thank you.